In this video, we're going to look at the equation of a circle. We're going to start off with the form x squared plus y squared is equal to r squared. This is the equation of a circle with a centre 0, 0, or the origin, and a radius of r units. Let's look at an example of this. What I'm going to do is draw up or sketch up an equation of the circle. So let's put one on. We'll have the centre at the origin, and I'll let this one be x squared, so x squared plus y squared is equal to 4. So this has a centre 0, 0 and a radius of 2 units. Often students write down that the radius is 4. This is the radius squared, so the radius is the positive square root of 4. Let's look at some points on here. If we have this point just here, this is 2, 0. 2 squared is 4, 0 squared is 0, that equals 4. This point just here is 0, 2. X is 0, 0 squared is 0, 2 squared, that gives us 4. This point just here, also we're going to have now negative 2, 0, and this point is going to be 0, negative 2. When we're looking at the equation of a circle, this is basic Pythagoras theorem. So if I chose a point just here, and this point here was going to be root 2, root 2. If we just consider a little right angle triangle, what we're going to have now is something like so. So we'll have a right angle triangle. The x coordinate is root 2, and I'll just draw this below. So what we'll have, let's just draw it up. The x coordinate is root 2, so that is the length now of this line just here, that's root 2. The right angle is just here, this is root 2, and this is going to be now the hypotenuse. The hypotenuse is the radius. So this is going to be the square root now of root 2 squared, which is 2, and then we're going to have now plus root 2 squared, which is 2, and that is going to quite clearly give us 2. So if we want, we can say the radius is 2, or the radius squared is 4. So that's what we have. What I've got is a graphing calculator, and if we look at that, we've got x squared plus y squared is equal to r squared. Currently I've got the radius set at 3, which means x squared plus y squared would be equal to 9. I can increase it. This would be x squared plus y squared is equal to 4 squared, which is 16. The radius has to be a positive value, so we can't have a radius of negative 1, but that's a radius of 1. And as you can see, it's fixed with its centre at the origin, and its radius is increasing and decreasing as I use the slider on R. So that is the basic equation of a circle, centre 0, 0. What we're now going to do is look at the equation of a circle when the centre is not at the origin, or 0, 0. We can write this as x minus a all squared plus y minus b all squared is equal to r squared. No more of a hassle. All we've got now is a centre a, b. So the centre is a, b. It's not negative a and negative b, it's just a, b. And the radius, again, is r, not r squared. So let's look at this in action. What I'm going to do is draw now a circle. So let's do it quite big so we can get some information on. And what I'm going to do is put a circle on. Let's just put one just here. Let's go, and we'll have it just here. What I'm going to have, and I'll just move it up slightly so we can get a lot of information on. I'm going to have a centre. Now the centre is going to be here, and the x coordinate will be a, the y coordinate will be b. I'm now going to choose a point on the circumference of a circle, or one that satisfies this equation, and that will just have an x coordinate of x and a y coordinate of y. At this stage I'm going to use Pythagoras again, and I'm just going to draw up a little right angle triangle. So if I do that, what I'm going to have is something that looks like that. Let's just make that slightly closer, so we're touching, there we go. And then we're going to look at the hypotenuse of this. The hypotenuse of that right angle triangle is the radius of the circle. It stays constant throughout its motion. So let's now look at this. This right here, this length here, consider that the x-coordinate here is x and the x-coordinate here is a. So when we use Pythagoras or the distance formula, we can say that this length right here, and I'll just change the colour so you can see it slightly easier, this is going to be x minus a. If we now consider this length right here, this is the y-coordinate of y, this is the y-coordinate of b, this is going to be y minus b. So going back to Pythagoras, this length squared plus this length squared is equal to this length squared. So this here is the radius, that's the length just here. So we can say from this, using basic Pythagoras theorem, that x minus a all squared plus y minus b all squared is equal to the radius squared. So let's just say we had some points. Let's pick some points that we can certainly work with that are nice and easy. So if I put these points right here, let's say that this is going to be the point 4, 1. I don't know why we've got arrows on. And we'll say that this is the point 10, 9. If we just look at this as a right angle triangle, again, you don't have to, but it might make sense. What we've got is the following. If we look now at the change in x, we would have the following. So let's go ahead. So we would have change in x. So this is 10 minus a, which is 4. So 10 minus 4 is 6. The change in y just here, this is y coordinate of 9. This is the centre, which is 1. B is 1. 9 minus 1 is 8. So if I wanted this length right here squared, and let's just call this r, we can say that r squared is equal to 6 squared plus 8 squared. R squared is equal to 100, so r is going to be equal to 10. And we know that from our Pythagorean triples. So the radius squared is 100, the radius is 10, and that is the equation of a circle with centre A, B. So, for example, if I had x plus 1 all squared plus y minus 3 all squared is equal to 16, we've got the centre of -1, +3, and then a radius of the square root of 16, which is 4. If I had x minus 0.5 all squared plus y plus 0.25 all squared is equal to 9, then we would have now a centre at 0.5, -0.25, and a radius of the square root of 9, which is 3. So nice and straightforward, and we can write it in that particular form. We'll see later in this video that we can use something called completing a square on a circle to put an equation in this particular form. So let's have a look at that circle. So this is x minus a all squared plus y minus b all squared. And I've just used capital R just so I can put a different radius onto the other one. So as you can see at the moment, our centre is going to be at 2, -2, and we can change that and move it around. Exactly the same as before, we've just moved away from the origin. So in this video, all we're going to do is work through some basic examples of finding the centre of a circle and the radius given this particular form. So we're asked to write down the centre of each circle and the length of its radius. So this one is straightforward. X squared plus y squared is equal to 25. We've got a centre of 0, 0. And the radius is going to be the positive square root of 25, which is 5. Clearly we wouldn't have -5 as we can't have a radius of -5. This one just here, the x-coordinate is 1 of the centre, the y-coordinate is -2, and the radius is the square root of 16. Square root of 16 is 4. The next one, we're going to have -5 on here, and we're going to have now positive 0.5, and the radius is going to be the square root of 32, and if we wanted to write this as a simplified surd, that would be 4 root 2. We need to be careful on the next one. We've got the brackets switch round. X squared here, x minus 14 all squared, and then y plus 2 all squared. So our coordinates are 14, -2, and the radius is the square root of 27, which we could write as 3 root 3 as a simplified surd. Okay, let's look at the next one. I'm just going to rewrite this one. X minus 3 all squared plus y squared is equal to 0.01. We've got x minus a all squared plus y minus b all squared, with b being 0, is equal to the radius squared. So on this one, the centre will be 3, 0, and the radius will be the square root of 0.01. And if we think about that, that is going to be 0.1. 0.1 times by 0.1 gives us 0.01, or if you like, the square root of 1/100th is 1/10. Okay, let's move on to this one just here. On all of these, the coefficient of the terms in x and y were both 1, or the x squared and y squared terms. They must be the same if they're a circle. If we had, for example, 2 and 3, it would be an ellipse. All I'm going to do here is take 2 out of each bracket. So 2 squared, then I'll have x minus 3 over 2 all squared, plus 2 squared, then we'll have y plus 5 over 2 all squared, and that will be equal to 36. 2 squared is 4, so I'm going to divide both sides of the equation by 4. X minus 3 over 2 all squared plus y plus 5 over 2 all squared will be equal to 9. From this, we can see the centre is positive 3 over 2, negative 5 over 2, and the radius is a square root of 9, which is 3. So nice and straightforward. All I've done is simply taken out this 2 squared and gone from there. Okay, let's look at G. X minus p all squared plus y plus q all squared is equal to r. So with this one, it's going to be p, negative q, and the radius is going to be the square root of r. Remember, this is the squared radius, so that one is slightly more challenging. This one just here, I'm going to take out now the p on each one, so it will be p squared, and then we'll have x plus 4 over p all squared. Taking out the p from this one, it will be p squared, y plus 2 over p all squared, and that will be equal to p squared. Dividing through by p squared, which looks quite convenient, we're going to have x plus 4 over p all squared plus y plus 2 over p all squared is equal to 1. So the centre will be negative 4 over p, negative 2 over p, and the radius will be the square root of 1, which is just 1. So all we've been doing is evaluating now the centre of the circle and the length of the radius using the form x minus a all squared plus y minus b all squared is equal to r squared. This is a circle, centre a, b, and a radius of r units. So that's what we've done. What we're now going to do is look at a slightly different form. We've seen before, if we have a quadratic equation, for example, x squared plus 2x plus 5, we can complete the square. So this is an expression. If I had it as an equation, let's go ahead and set this equal to 0. Then what we would do is complete the square. We take x and half the coefficient of a term on x, so x plus 1 all squared, and then subtract away this number squared and add the existing 5. So we could say now that x plus 1 all squared plus 4 was equal to 0, and we can see that's in completed square form. There are no real roots to that particular equation, as we can't take the square root of a negative number to get a real solution, but I was just showing how to do it. We do exactly the same when it comes to a circle. So in question 6 it says find the centre of each circle and the length of its radius. What I'm going to do is complete the square on the x terms, complete the square on the y terms, and put it all back together. So that's now just highlighting these with their signs. We need to be careful, and we'll do that. So let's complete the square on the x terms. So it'll be x plus 1 all squared, and then we'll have minus 1. If we consider the y terms, it will be y minus 2 all squared minus 4. So this is now equal to 20. So I can write this now as x plus 1 all squared plus y minus 2 all squared will be equal to 20 plus the 5, which is 25. So we can see that the centre will be -1, 2, and the radius will be 5. So all I've done is gone ahead, completed the square, and simply added now the -1 and the -4 to both sides, and that's given us now the equation of a circle in the form x minus a all squared plus y minus b all squared is equal to r squared. If you're at this point in the course, you've done completing the square, so I'll assume that you're relatively happy. Okay, let's put a circle around the x's there, and then get a different colour and put a circle round the y's. So I'm going to complete the square on this right here. So let's go ahead and do that. So we'll have now x minus 3 over 2 all squared minus 9 over 4. 9 over 4 is 2.25, and then we're going to have plus y plus 1/2 all squared minus a quarter, which is 0.25, and that is going to be equal to 13.5. What's that give me? 2.5, adding that on, so we'll have x minus 3 over 2 all squared plus y plus 1/2 all squared is equal to 16. This now gives us a centre of 3 over 2, comma, -1/2, and a radius of 4 units. And we've done that one. So hopefully it's making a bit of sense, and it's relatively logical. If we look at this one, we only need to complete the square on the x terms. So x minus √3 over 2, which we need to square. And then we're going to subtract away from that 3 over 4. The y squared now has no term in y, and that's what we end up with, and that's 24.25. So x minus √3 over 2 all squared plus y squared is equal to, what's that going to give me, 25? So we've got now a centre of √3 over 2, comma, 0, and a radius of the square root of 25, which is 5. Okay, with this one now, I'm just going to get everything onto the left-hand side. So what we've got is x squared plus y squared plus 2x minus 4y is equal to 0. Now you could have had x squared plus 2x. I don't really mind. I prefer the x squared and the y squared terms at the beginning. So completing the square, what we're going to have now on here, let's have a look at that one. In fact, just looking at this one, we can't do this one as it's going to be a minus. So that one, let's go ahead and look at that. That would be a minus. Now that isn't going to give us a circle. So that looks to be a trick one. So the answer is can't do it. This would need to be minus to now make that a circle. So let's just say if it was, and that had been a negative, then we would have gone ahead, put a positive here, and then completed the square. Okay, let's look at the next one. This one looks a bit of a mess because we've got these p's involved. Let's complete the square now on the x's. So do be careful on that one. That was looks like it was trying to catch us out because it's certainly not a circle. So let's go for this one. So x plus p over 2 all squared minus p squared over 4. Let's now look at this one, and then we're going to have plus y minus 2p all squared minus 4p squared, and that is going to be equal to 17p. Okay, this looks a bit of a mess. So what we're going to have is x plus p over 2 all squared plus y minus 2p all squared is equal to 17p. And then this is going to give us, now what's that going to give us? That's going to give us plus 17 over 4p squared. Okay, now we need to look at this, and the radius is the square root of this. So what we're going to have then is we'll have negative p over 2 comma 2p, and the radius is going to be the square root of 17p, and then we're going to have plus 17 over 4p squared. Now you could tidy that up. Let's see if we could. Let's take, so if we take out, it'll be root 17, root 17p over, what are we going to have, over 2. Let's think if we can do anything, multiplied now by the root of, that's going to give me 4 plus, that's going to give me p. A quick guess. I think that looks, but whatever it is, it's horrible. So again, this is just testing your ability to be able to rewrite these or just write it as a messy answer. It really doesn't matter. Okay, let's move on and look at the next one. This one, we got 2x squared plus 2y squared plus 4x minus 3y is equal to 26. The first thing I'm going to do is divide through by 2. X squared plus y squared plus 2x minus 3 over 2y is equal to 13. Completing the square, x plus 1 all squared minus 1 plus y minus 3 over 4 all squared minus 9 over 16 will be equal to 13. So what we're going to have, x plus 1 all squared plus y minus 3 over 4 all squared is going to be equal now to 14. And then we're going to have plus 9 sixteenths. So again, a messy answer. So if we do that, 14 plus, what we're going to have, 9 sixteenths. What's that give us now? We'll take the square root of that. Root 233 over 4. So that is a radius, 233 over 4. That is a radius. And then the centre will be negative 1. Let's put negative 1 comma, negative 1 positive 3 over 4. So again, messy, expect them to come up, expect them to be roots. You never quite know. It's not always going to be 25, 16, 9 and so on. Just be ready for something like that. Okay, let's do the next one. What have we got now? Y squared plus x minus 3 all squared is equal to 8y. Let's rewrite this. The x minus 3 all squared is already put in a complete square form. So let's now plus y squared minus 8y is equal to 0. So x minus 3 all squared plus y minus 4 all squared minus 16 is equal to 0. So x minus 3 all squared plus y minus 4 all squared is equal to 16. Nice and straightforward. 3, 4, and the radius is the square root of 16, which is 4. So that one was quite straightforward in the end. All we've done is now subtracted 8y from both sides, completed the square on the y terms, and then got this constant and taken the square root. Okay, let's finish with this one. This one looks quite horrible. Let's go ahead and write this. So we got qx squared plus qy squared. So that's fine. Minus 6x minus 2y is equal to 0. I'm going to divide through by q. So what we'll have is x squared plus y squared minus 6 over qx minus 2 over qy is equal to 0. Completing the square, x minus 3, that's half, x minus 3 over q all squared, and then we can have minus 9 over q squared plus y minus 1 over q all squared minus 1 over q squared is equal to 0. So x minus 3 over q all squared plus y minus 1 over q all squared will be equal to 10 over q squared. So we can see from this now that the centre is 3 over q, comma 1 over q, and the radius is going to be root 10 over q. And that now is the square root. So again, quite tricky. The only one that we have to be careful on is this one right here, because it isn't a circle. I think that one's done to catch us out. But apart from that, we're simply completing the square, as we've done in previous units, to write it in the form that we want. And that form is x minus a all squared plus y minus b all squared is equal to r squared. Centre a, comma b, and a radius of r units.